Hello everyone. Today we are going to learn the fourth chapter. Today's goal is to solve the problems from 41 to 60. Let's start. Force remaining constant if the mass of body increases, its acceleration is likely to. We know very well, according to Newton's second law of motion, F net is equal to mass into net acceleration. Force remaining constant, then write here acceleration equal to net force by mass. If force is constant, then we can write acceleration is inversely proportional to mass. That means greater the mass, acceleration is decreases. So if the mass of body increases, its acceleration is likely to decrease. So option 3 is the right answer. Next, go to 42nd question. Go to 42nd question. Right. A force F produces an acceleration A in a body. The same force produces an acceleration 4A in another body. Then the mass of other body is. According to Newton's second law of motion, consider a body of mass M. A body of mass M. So a force F acts on a body of mass M. It produces an acceleration A. Okay. So according to Newton's second law, we can write F net is equal to mass into A net. Then same force that is F. Look, what are the mass of other body is. Consider the mass of this body is x. This force produces an acceleration of 4a. So according to Newton's second law, we can write F is equal to, in the place of mass that is x, and acceleration is 4a. So substitute in the place of F ma. So ma is equal to x into 4a. A gets cancelled. Then x is equal to m by 4. That means the mass is 1 by 4 times of, that means the mass is 4 times smaller than the mass of first body. So option 2 is the right answer. Let's go to 43rd question. A vehicle has a mass of 1500 kg. If the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square, the force of friction between the vehicle and the road is. Here consider a vehicle, its mass is 1500 kg. If the vehicle is to be stopped with a negative acceleration means which opposes the motion of the body. So motion is in this direction and acceleration is opposite to the direction of motion of the body, that is 1.7 meter per second square. So this direction is considered as positive, then this acceleration is taken as negative. Then calculate the force of friction between the vehicle and road. According to Newton's second law of motion, F is equal to ma. In the place of mass, write 1500 kg, and in the place of acceleration, that is minus 1.7 meter per second square. So 0.0 gets cancelled. 150 into 17, that is equal to 2550 Newton. So that is minus 2550 Newton. Option 3 is the right answer. Let's go to 44th question. The mass of aeroplane is 2.5 ton. Its engine develops a force of 8750 Newton before taking off. The acceleration of the aeroplane at the time of takeoff is. See, a ton means we know very well 1 ton equal to 1000 kg, and force is given, mass is given, then find acceleration. According to Newton's second law of motion, net acceleration is equal to net force by total mass. In the place of net force here, 8750 Newton by total mass is equal to 2.5 ton. Ton means in the place of ton write 1000 kg. 1000 kg. Here point 0 gets cancelled. 0 gets cancelled. 25 1 25 3 75 and 125 25 25. So 5 7 5 2 7 by 2, that is equal to 3.5 meter per second square. Option 3 is the right answer. Let's go to 45th question. A truck starts from rest. Starts from rest means u equal to 0 and rolls down the hill with a constant acceleration. It travels 400 meter in 20 seconds. If the mass of the truck is 7 metric ton, the force acting on it is. So according to Newton's second law of motion, F net is equal to mass into net acceleration. Here mass is given 7 metric ton means that is equal to 7 into 1000 kg, and calculate acceleration by using second equation of motion, that is S equal to ut plus half at square. In the place of u, 0 plus half acceleration a t square. Time is given 20. Square means 20 into 20. So it covers a distance of 400 meters. So in the place of S, write 400. So 20 into 400, this one gets cancelled. 2 comes 2 equal to acceleration. So acceleration equal to 2 meter per second square. Substitute here 2 meter per second square. That is 7000 into 2. That is equal to 14,000 Newton. So 14,000 Newton is the right answer. Option 2 is the right answer. Let's go to 46th question. Forty-sixth question. Right. When a force of 1 Newton acts on mass 1 kg, which is able to move freely, the objects move with A. So according to Newton's second law, F net is equal to mass into A net. If force magnitude is 1 Newton means mass should be 1 kg and acceleration should be 1 meter per second square. So 1 kg mass moves with an acceleration of 1 meter per second square. Option 4 is the right answer. Let's go to 47th question. When net force acts on an object, the object will be accelerated in the direction of force with an acceleration proportional to. Here when a net force acts on an object, the object will be accelerated in the direction of force. The direction of force. Then what happens? Greater the force, greater is the acceleration. So acceleration is directly proportional to force. So the acceleration is proportional to force of the object. So 47th, option 1 is the right answer. Let's go to 48. The rate of change of momentum gives. So according to Newton's second law of motion, net force acting on a body is equal to rate of change of momentum. So rate of change of momentum gives force. So option 2 is the right answer. Let's go to 49th. Force can be defined on the basis of. So Newton's first law of motion gives the concept of inertia, and when net force is equal to 0, what happens to body? And Newton's third law of motion related to the pair of forces. Force always exists in pairs, but Newton's second law measures the force and defines the definition of force. Defines the force, definition, and the unit of force. The unit of force. So Newton's second law measures the force and defines the force, and it defines the unit of force. So force can be defined on the basis of Newton's second law of motion. Next 50. Newton's second law gives the measure of, that is force. Option 2 is the right answer. 51st question. A body of mass 40 gram is moving with a constant velocity of 2 cm per second on a horizontal frictionless table. the force on the table is. So consider a table. It's a table. So a body of mass 40 grams is moving with a constant velocity. Here velocity is constant. If velocity is constant, the net acceleration is equal to 0. If net acceleration equal to 0, the force on the body, here, force on the body, force on the body is equal to 0. But here force on the table, question is force on the table. Force on the table, that is nothing but weight of the body. That is nothing but weight of the body. So weight of the body is equal to nothing but m into g. Here mass is given 40 gram and g value in centimeter per second square, that is 980 centimeter per second square, that is equal to 40 into 980, that is 39,200 gram centimeter per second square, that is time. So the option 2 is the right answer. 51, option 2 is the right answer. Let's go to 52nd question. A number of discs, each of momentum m kg meter per second, are striking a wall at the rate of n discs per minute. The force associated with these discs in newtons would be, according to Newton's second law of motion, F net is equal to rate of change of momentum. Here change in momentum is nothing but m kg meter per second. M kg meter per second. And dt here at the rate of n disc per minute, n disc per minute, in the place of minute write seconds. So n disc number of disc per time, number of disc per 1 second, number of disc per 1 second, that is equal to nothing but frequency. Frequency equal to n by 60, then time period is nothing but reciprocal of frequency, that is 60 by n. So substitute time is equal to 60 by n. So it is equal to m by 60 by n, that is equal to mn by 60. So option 1 is the right answer. Let's go to 53rd question. By applying a force of 1 Newton, one can hold a body of approximate mass is. Here one can hold. By applying a force of 1 Newton, one can hold how much mass? We know very well. Suppose this mass is m, then its weight is equal to mg. So the least force required to hold the body is mg. That means here 1 Newton should be equal to m into g. Already we know very well, according to Newton's second law of motion, F net is equal to mass into A net. So the SI unit of force is Newton, the SI unit of mass is kg, the SI unit of acceleration is meter per second square. So when a 1 Newton force acts on a body of 1 kg, it produces in a body of acceleration 1 meter per second square. So in the place of 1 Newton, we can write 1 kg into 1 meter per second square. So here G value, suppose G value is taken as 10 meter per second square, and mass. So mass should be 1 kg. Mass should be 1 kg. Then only it is equal to 1 Newton. So in the place of 1 Newton, we can write 1 kg into 1 meter per second square. Already here 1 meter per second square is there. Here 10 is there. So suppose I can write 100 grams here. Suppose the mass is 100 grams. If you multiply this 100 into 10, that is equal to 1000 grams into 1 meter per second square. In the place of 1000 grams, we can write 1 kg into 1 meter per second square. So that is equal to 1 Newton. So 1 Newton means if G value is taken as 10 meter per second square, then mass should be 100 grams. That means here if the mass is 100 gram, then by applying 1 Newton force, we can hold the 100 grams mass. So option 2 is the right answer. Let's go to 54th question. China weights. China weights are wrapped in straw or paper before packing. This is this is so we know very well impulse is equal to average force into time, or impulse is equal to change in momentum. From impulse momentum theorem, what is impulse? We know very well a very large force acts in very short interval of time, right? From this we can write force is equal to rate of change of momentum by time, that is equal to average force. If time of contact increases, it reduces the force. That means if China whites are wrapped in straw, it increases the time of impact. If it increases the time of impact, then the impact of force decreases on the China weights. So option 1 is the right answer. Let's go to 55th question. A force of 20 Newton acting on a body of mass 10 kg is found to double its velocity in 8 seconds. Find its initial velocity is. Here a force of 20 Newton, body of mass 10 kg. Suppose its initial velocity is u. After 8 seconds, its velocity doubles, that is equal to 2u. So we know very well, according to Newton's second law of motion, F net equal to rate of change of momentum. We can write that one m of v minus u by t. Substitute here in the place of force 20 Newton, mass 10 kg, final velocity is 2u minus initial velocity is u by time taken is 8 seconds. 10 1 10 2. So 2 into 8, that is equal to 16, 2u minus u, that is equal to 16 meter per second. So 55th, option 3 is the right answer. Let's go to 56th question. A machine gun fires X bullets per second into a target. Each bullet weighs mkg and has a speed of y meter per second. Find the force in Newton necessary to hold the gun in position. Consider, suppose it is a machine gun. Here x bullets per second, each mass m, and its speed is y meter per second. We know very well, when bullets moves in the forward direction, gun recoils backward with some velocity. To hold the gun in position, you have to exert a force in the forward direction, that is equal to rate of change of momentum of bullets. So net force is equal to rate of change of momentum of bullets. So here, how many bullets are there? X bullets are there. So x bullets per second into each of mass m of v minus u by t. So we can write this is x, time is 1 second, into mass m, final velocity is 0 minus initial velocity is y. That is equal to m of x y. That is minus. That means you have to exert the force. That means this force is backward. You have to exert the force in opposite direction to this. That how much that force is, that is equal to rate of change of momentum of the bullets, that is equal to mxy. Option 2 is the right answer. Let's go to 57th question. Right. A block is kept on a horizontal rough surface. Here consider it is a horizontal rough surface. A time dependent horizontal force, that is capital F, where K is positive constant. Here when this force increases, that means when this force increases, friction also increases. If there is no relative motion, between the two surfaces, the friction which comes into play, that is nothing but static friction. Static friction is a self-adjusting friction. As applied force increases, static friction also increases up to some value. The maximum value of static friction is called limiting friction. That means up to certain time. That means initially time is 0. When time is 0, what happens? There is no relative motion, so acceleration is also 0 up to certain time. Up to certain time. If time is greater than this T naught, then applied force is greater than the limiting friction. Then which friction comes into play? This time the friction comes into play is kinetic friction. When kinetic friction comes into play, then right net force is equal to capital F minus friction. Already we know very well friction equal to mu into n. Here in the place of n we can write mg. So right in the place of F, that value is kb minus in the place of friction mu mg, F net is equal to ma. From this A is equal to k by m into t minus u, gets cancelled, that is u. So from this here, if t is less than t naught, the applied force is less than the maximum value of friction. So the body is at rest. That means there is no relative motion. So the body is at rest. The friction is static friction. In this situation, the acceleration is equal to 0. But as time increases, that means this time the time is greater than t naught. Then this time there is a relative motion between the surfaces. This time the friction comes into play is kinetic friction, and this time the acceleration is there, and this acceleration is directly proportional to t. So observe the graphs. So in option 4, up to t naught, here up to t naught, here time is less than t naught, the acceleration is 0. After if t is greater than t naught, the acceleration is directly proportional to t. So option 4 is the right answer. Let's go to 58th question. Unit of impulse is, we know very well impulse is equal to average force into time. So already we know very well SI unit of force is Newton and time second. So the unit of impulse is Newton into second. Option 3 is the right answer. Option 3 is the right answer. Next, 59th question. Next. Variation of force with time for a body moving along a straight line is shown in figure. The impulse imported in the time interval 0 to 8 seconds is. Here graph is force time. We know very well area under force time graph gives impulse. Area under force time graph gives impulse. So calculate area here, this area, and this area. So first I am calculating here. So here impulse area, this is in the, observe here this area, it is in the form of triangle. Already we know very well area of triangle, that is equal to half into base. So base is here, this is 2 seconds into height, this is minus 2 Newton. So that is minus 2 Newton. 2 gets cancelled, that is equal to minus 2 Newton. Then second, here calculate the area. Here also, here half into base is 2 seconds into height, that is plus 2 Newton. So 2 gets cancelled, this is equal to plus 2 Newton. If you calculated this one, this is also plus 2 Newton. Then third area, so that is also the shape is looks like triangle. So area of triangle half into base 6 to 8, that is 2 seconds into minus 2 Newton. 2 gets cancelled, that is equal to minus 2 Newton. So total area of force time graph gives impulse. The total area is minus 2 Newton plus 4 Newton minus 2 Newton. So minus 2 Newton gets cancelled. Minus 2 plus 4 and minus 4. Minus 2 minus 4 plus 4, that is equal to 0. So total area equal to 0. That means impulse is equal to 0. So the option 1 is the right answer. The answer is 0. Next, 60th question. impulse is equal to, we know very well, impulse is equal to change in momentum. So option 2 is the right answer.